Hi there. In this video, we're going to do an overview of statistical inference. So we've seen some of this before, but we're going to come back to it more formally now. And so inferential statistics is inferring to the population versus descriptive statistics, which we were just doing a bit ago, where we were describing a data set that we already had. Okay, so inferential statistics has two areas to it. One is called estimation, and this is confidence intervals is one example of this. You may have seen a poll online or in the media, and they have some margin of error like plus or minus 3%. So an example of this is polling. So we'll look at things like that. And then another area of inferential statistics is determining whether a result is significant or not. And this is called hypothesis testing. So we will, we've already seen one example of this, which was the Kiki-Booba test. To test whether there was a significant relationship between the words and the shapes. So we'll come back to this and show some more examples. But in this general overview or introduction, I want to go back to population parameter, sample, and statistics. Oops, I should be a comma there. Population parameter, sample, and statistic. So let's review what those mean, and then we're going to look at the notation for a bunch of different cases, okay? So I'm going to start with the population with a big circle, as big as I can draw in here. And that represents our whole population. Right, that is our whole group of interest. Okay, could be the entire adult population of the United States, entire population of the United States. It could be PCC students. So whatever group of interest we are studying, that's our population. And then for the population, what we want to know is called the parameter. That is the thing we want to know, what we want to know. Okay, but it's really hard to ask everybody or measure every part or whatever. So what we do is we take a sample, and we want some kind of random sample, right? So the sample is this a subset. I'm going to say a random, or I could say representative subset of the population. And then the thing we calculate is called the statistic. That's the name of the class, right? Okay, so the statistic is, it's the thing we want to know, but it's calculated from our sample. Okay, so keep in mind the parameter and statistic are the same quantity, like a mean or a proportion, but we often can't know the parameter, so we use the statistic to estimate that, okay? So I'll write that again down here. Okay, so that is just a little review, and that's really helpful because we're going to be using that a lot in this section. So now on this chart down below, got a bunch of different things we're going to be studying throughout our weeks in inference. So the type of variable, we've got four different, well, we've got categorical and numerical that you've seen before. And then we're also going to look at differences of two things. So let's do categorical first. And it has to be a yes, no, or it can be made into a yes, no. It has to be a binary variable for this to happen. For example, what proportion of people support this candidate? There might be more candidates, but we just focus on one to make it a yes, no. Our quantity of interest there is a proportion. What we're calculating is a proportion, and the letter for that is P. That's our population parameter. And then the thing we're using, the statistic we're using to estimate that is p hat. Okay, and remember that's pronounced p hat. Statisticians like to put accessories on their variables, and when they do that, that means it's coming from data or a sample. Okay, so this is our sample statistic, also called a point estimate. Okay, that means if we had to estimate this with a single point, a single value, that would be our estimate. But as you'll see, we're going to put a range around it, like the plus or minus 3%. Okay, so that's a categorical variable. And then also for numerical variables, we would be interested in the mean. So this would be like a number of hours of sleep someone got. Our mu, it's written mu if we were going to write out the name of the Greek letter mu, but it's pronounced like M-E-W, like a cat. Mu, and then that's our population parameter, which we often, not with proportion, but we often use Greek letters for parameters. And then x bar is our sample statistic or our point estimate. Okay, now we're also going to get into differences of two proportions and differences of two means. This is really interesting when you want to compare two groups. Okay, so difference of two proportions, we would write P1 minus P2, or we might change the subscript to a letter or something to represent the group, any kind of subscript. And so that's our for the population. For the sample, the statistic would be P hat 1, that's how I would probably say it, P hat 1 minus P hat 2. Okay, and then similarly with two numerical variables, if we wanted to compare the means of two groups, we would say that's mu1 minus mu2, and for our statistics, it would be x bar 1 minus x bar 2. Okay. So another thing I want to mention about these parameters and statistics. So the population parameter is fixed. So keep in mind that is what it is, right? So we could also call this the theoretical true value. I'm saying theoretical because we usually don't know it. That's why we're doing statistics in the first place, right? But it is what it is. It's not moving. It's a fixed value, okay? But we don't know what it is. Now, that's different from our statistics because those are known. We can get a sample and calculate them, but they vary based on a particular sample. So if we get a sample of 1,000 people, our statistic wouldn't be the same as a sample from a different 1,000 people, right? It might be close, but there's just normal sample-to-sample variation or regular sample-to-sample variation. Sometimes it's called sampling error, but it's not that anyone made a mistake. It's just normal, regular variation. Okay, so that's a very important distinction to know, is that our parameter is fixed wherever it is. We just don't know where it is. The statistic we know, but we have variation to it. They vary by sample. Okay, so we'll get into more of that as you see when we start doing simulations. Okay, to practice all this vocabulary and symbols, let's do an example. Example 4 here, we're going to identify the parameter and statistic of interest in each situation. We're going to put the units whenever we can, right? Which would be for numerical variables. Okay, so this first one might look familiar to you because we've done the YouTube videos before. In a study of 100 YouTube videos, 2% of the videos were cat videos. Okay, so I'm going to start, it doesn't matter which way you start, but I'm going to start with the statistic because that one's often easier for people. So I'm going to say the statistic is, okay, and it's 2%. That's the number because that's saying it's from a sample. Now we need to look at which letter do we use, right? So we know it's one of these, and it's a proportion. It's a yes, no. Is it a cat video or not a cat video? So that's a p hat. P hat equals 2%, okay? Which is the percentage in the sample that are cat videos. Okay, and then I'm going to write the statistic is used to estimate P, which is the parameter. I'm going to abbreviate a little bit because I'm running out of space. The percentage of all YouTube videos that are cat videos. Okay, so you can see there's many ways to write this out. You can write it out in your own way, the way that makes most sense to you. But the important part is the statistic is P hat, and it's the percentage in the sample that are cat videos. And that is used to estimate P, which is the parameter. I could have said parameter, estimate the parameter. P, which is the percentage of all YouTube videos that are cat videos. Okay, we get an idea. If you want to try the next two, pause it and then come back. Okay, or we can do it together. So a phone company wants to know whether teenagers send more texts than adults. Okay, so now I'm seeing two groups, teenagers and adults. They collect the number of texts sent per day. Okay, that sounds like units to me. Number of texts per day for a month from 1,000 randomly selected adults and 1,000 randomly selected teens. Okay, great. So this looks like a difference, right? So it's going to be one of these two bottom rows is a difference of two proportions or a difference of two means. Okay, so now we look at what we're measuring. Number of texts sent per day. Is that a percentage proportion, or is that some kind of average or something we're measuring? Number of texts per day, that's numerical, right? So this is a mu1 minus mu2 situation, or x bar 1 minus x bar 2 situation. Okay, so I'm going to write it in a similar form as this one. I'm going to start up here because I'm going to need all my space. The statistic, and they didn't tell us what it was, right? So we're just going to use the symbols. The statistic is x bar, I'm going to use an A, x bar A minus x bar T. Okay? You could use a lowercase, it doesn't matter. It helps you remember which is which, right? And it could have switched the T and the A as well. They just want to know if there's a difference between the two. Okay, so we've got, this is the average, actually it's the difference. The statistic is this, which is the difference in the average texts sent, and I'm using my units, per day in the sample, or let's say by teens and adults in the sample. Okay, and then I could say this estimates mu A minus mu T, the parameter, which is the difference in the average texts sent in the population. Okay, how does that sound? So I did abbreviate a little bit, but I think between both of those you get the idea that it's the average text sent per day by teens and adults in the sample. I could have written by teens and adults in the population as well if I had a little more space. But I did it to myself. Okay, one more. A large company is interested in the average number of hours. Okay, average number of hours its employees spend on email each week. Okay, they collect data from a random sample of 200 employees. Okay, random sample of 200 employees. Okay, again, we don't have the value for the statistic, but we're going to, oops, let me bring the chart down for a second. Average number of hours. We're not comparing two groups. I don't see two groups. I see a single group. So we're looking at one of the first two rows in our table. And is it something we're measuring, or is it a percentage proportion? It's an average number of hours, so it's a mean. It's an average. Okay, so I'm going to say the statistic is, that would be X bar, the average number of hours, and I'm really just pulling the context right out of the question, number of hours that a sample, and I could add in the 200 if I want, or I could just say the sample of 200 employees spend on email. Okay, let's switch colors again when I switch to the parameter. I'm going to say this estimates the parameter mu, which is what's our population of interest. This is a large company, so we're not talking about whole US or anything. We're talking about a large company. That's the population. This estimates the parameter mu, the average number of hours spent on email. They might be having a productivity issue, spent on email by all employees in the company. Okay, great. Thanks for watching, and I'll see you in the next video.